Hey everyone, this is Cassidy. Today we're going to be talking about how to determine the new K value when the equation is altered. So let's say you're given an original equation and a manipulation happens to this reaction. How do you change the equilibrium constant when you do that? So the very first situation that we're going to have is if you reverse the equation. So when I say equation, I mean reaction, right? It's the same thing. If you reverse the reaction, you're going to do the reverse on the K value. So for example, let's say we have a reaction here. N2 plus O2 is 2NO, and it's in equilibrium because we're talking about our equilibrium constant, which is K. And let's say this is our K value, 2.0 times 10 to the negative 25th. Well, if we do the reverse of the equation, so let's just flip the equation. If we want to calculate the new equilibrium constant, we do the reverse. So taking the reverse of something in a mathematical sense is just doing 1 over that value. So this is going to be our very first example of manipulating our equation. The second thing we could come across is multiplying the equation. When we multiply the original equation, we're going to raise our K value to that power. So let's see what that looks like. We have the same thing as last time. But now let's say we're interested in figuring out how the equilibrium constant would change when we multiply the equation by 4. So let's say now we have 4 N2 molecules, 4 O2 molecules, and 8 NO molecules. So to find that new K value, what we're going to do is just take the original value and raise it to the power of 4. So whatever we multiply by, that's what you're going to raise it to the power of. The last step that could potentially happen is the hardest one to kind of understand. So if you're adding two equations together, you're going to multiply the K values. So here are two equations. We have our A equation, which is what we've been dealing with this whole time. And then we have the B equation. Now, we use those at the same time because we want to add them together. So when we add the equations together, this is what it looks like. So basically we have two O2s. Let's see. It looks like I made a mistake there. So actually, let's get my little cursor out. This kind of goes away right there. Here we go. So this 2 goes away. That was a mistake. So now what is happening is that on the left side of the equation, we have an NO right here. And then on the right side, we also have an NO. So since those are on opposite sides, we can kind of cancel those out like that. So those disappear. We have an N2 left over. We have two O2s left over. And then this NO2 is carried down. So that's what it means when we add equations. So now when we're adding our equations, we take our K1 value and we just multiply it by our K2 value, and that's going to give us the overall K3 value. So in the next video, I'm going to create an example where it's going to utilize all of this so it can help you understand that more.